103. Time to start.
Okay.
I think mine's on.
Okay. Okay. So, workshop, Rajiv, and this is me, Badruddin. So this is a joint session, and it's not really. We want it to be like an open forum discussion. There are lots of open questions. There are some problems. So I want to get feedback. I want to answer some questions, get feedback, and get some maybe in the process. We put some agenda for next year, and maybe solve some, or at least have some ideas how to proceed for the coming year. So set some direction. Yeah. So this is more of a current state and of OCP. We have too many form factors. Essentially, there are lots of solutions. If you go to the website, RAX 1921. Mark probably can speak about this, right? 24 width, half width, 1/3 width.
Yeah, too many is in the eye of the beholder, I suspect.
Sure,
but it's too many for us.
Yeah. Too many firmware and management solutions. I mean, whoever in sessions. So IPMI, there is OpenBMC, which is has its own kind of custom interface, and then there is Redfish, OpenPCRE. So there are lots of. This is just to name a few. And then we don't have any well-defined feature sets even on these solutions here, right? And we'll dig a little bit deeper on one feature set. We wanna essentially hear from you what's really missing. I mean, do you see something missing, or do you see something that is not needed? So either way. So the idea here, if we can converge on a fewer standards, fewer features, I think maybe we can come up with a better solution that meet the needs of all the OCP customers.
No, I think this is a good question set to start discussions. Personally, if I think about it, 19-inch versus 21-inch, I think an argument could be made that people want different things. They have different requirements, and difference is good. I think the way I look at it from our perspective is, as technologists, we sort of lose focus on somebody has to buy it, somebody has to build it before somebody can buy it. And there are as many variations as there are that impacts the supply chain as to what can you buy, how quickly can you buy. So even though thinking about solutions, which could be irrespective of the outside form factor, 19-inch, 21-inch, DC bus bar, no DC bus bar, AC power supply, no AC power supply. But at the end of the day, the building blocks, the Lego building blocks, they could be the same, which could be leveraged. So that's one way to look at it, which sort of helps the supplying community. So I think those are the kind of discussions we want to have, what people really need, what they really want, and hear from you as to what your pain points are. Are you consuming? First of all, I think the fundamental question that we should have asked first, are you consuming OCP in any way, shape, or form? Let's just start from there and say, okay, what is it? Why is it you're consuming? If you are, that's good, welcome. If you are not, what's preventing you to bring it, right? So see how.
Yeah, and in the server track this morning, we heard from several vendors who are trying to cross over between open rack and 19-inch. And one thing that I kept hearing was, well, in the 19-inch rack space, the enterprise space, customers want this. Cloud guys want that, and as part of OCP, we should make it so that these feature sets, firmware, all this sort of thing, they're the same. If you buy an OCP server, it gets managed the same way, it gets handled the same way, it's firmware updated the same way, all that sort of thing. Regardless of the form factor. The form factors, it's hard to predict what the future is going to be. You can always change a PC board, that sort of thing, but the software is the magic that I think will really, that's a big part of what will really make it OCP.
The floor is open for Sure.
I'll be Raven Start.
I'm Jay. I'm a software developer working on OpenStack Ironic for Rackspace on Metal. So seeing the firmware management solutions here is something I'm really interested in. One thing that I will mention, as you were saying, kind of almost sounded like finding a management standard that was like a lowest common denominator between all of them. I want to really discourage that approach. And here's why, is that what I see when I work on OpenStack Ironic is that the fully featured solutions, ones that work really well, are all tied in directly with proprietary hardware and not with Open Compute for that exact problem. You know, every single Open Compute vendor can't sponsor, and every consumer of Ironic can't sponsor development of drivers with these advanced features. So even if they aren't required, having the advanced features like, let's say, a virtual media, or the ability to change boot devices, or especially things like firmware flashing, it's incredibly important that that be a consistent interface, because then it allows us to sort of complete the open ecosystem of us coming from the hardware management side and provisioning with Ironic. We can write one driver and then interface with whatever features happen to be available in that thing. I'm not necessarily saying that we have to say your BMC must implement this list of features, but if you do implement it, it should look this way. It should work this way. The API should be same between them. And then, you know, when it comes to us, it's a lot easier for me to develop one driver that's going to hit all of the Open Compute vendors than it would be to, you know, sort of everyone boils down to the lowest common denominator, IPMI. You know, if you want firmware upgrades, if you want to, you know, put RAM disks on a machine without Pixie booting, you're going to have to go with a more proprietary solution. And I think that's a huge gap that we've seen in that Ironic community so far.
Can I just ask you a question?
Yeah,
sure. A little bit more. So what I heard, being the hardware guy, was you really like the full featured set, but you don't like proprietary lock-in.
Well, let me put it to you this way. I was kind of laughing when you were talking about, oh, the enterprise wants this and the cloud wants this. I'm stuck in the middle. I do Rackspace on Metal. I can't trust my root users, so I need some enterprise features there. But I also, part of the value we provide is making it cloud. So I kind of need the convergence of those features. I understand not everyone needs it. I understand that's added cost for a player like, you know, maybe Microsoft or Facebook that don't need those advanced features. But having them there, having a standard there for them means that if I, as a consumer for my product, need it, I'm able to go consume it. And yes, I do want those features, because the ability to say, put a provisioning RAM disk on a server via virtual media instead of having to Pixie boot it is orders of magnitude more secure. But today I can only do that by writing hardware or vendor specific code, if it's even possible in a programmatic manner at all.
I was just going to follow up and say, well, what if, you know, I think we have to ask the question, what would have to be true for this to work without vendor proprietary information? So that's.
I mean, I think when I look at like Redfish, I see that as sort of a positive step forward for defining the interface. Like, I'm a developer. I care about APIs. I care about interfaces. You know, when I have my engineer hat on, I care about what's underneath the hood. But from an Ironic perspective, it's more about, you know, for every single Open Compute machine out there, if I want to do X, I press this button, even if it's not there. And what I see happening instead is it's sort of like it gets whittled down to the lowest common denominator feature set. That gets standardized, and all the advanced stuff is, you know, I care about it being proprietary versus open, but the real problem is that the interfaces are just wildly different.
Thank you.
So essentially what you mean standardization. We have to standardize and provide the right.
Yes, but make sure, don't standardize to the lowest common denominator.
Yes. Yeah,
Standardize with a broad view, even if not all those features.
Richer feature set.
Exactly.
All right, so Bob Thurston from Fidelity Investments. So, so I agree actually with a lot of the different stuff and a lot of what you got up there. So we'll just focus on the firmware, the management part of it. You're right. There's all these standards coming out. So Mark's Fisher from Apple actually posted on the email for hardware management about a year ago. So, you know, we need 5 commands, right? And, you know, power on, power off, you know, this and that, and that's it. Nothing else, just 5 commands, right? So So in it being an enterprise, there's different levels, just like what you're talking about, right? So within the enterprise, I have traditional environments where I have one physical box where I install one application, and if that application goes down, I've got to get that box fixed as quick as possible, and I want all the features to get that box back up, right? So that's the high level feature, EMC is the diagnose and all of this, right? But I'm also doing scale out, right? I'm doing cloud, and I'm doing Hadoop, and I'm doing, scale out storage. And in that environment, if something fails, I just need to shoot it, and go replace it next Saturday or 2 weeks from now and send it back to factory to be fixed, right? So I don't need as functionality. And I don't want as much function. I actually don't want the code to be there. Because we actually have in the high level firmwares, we have a lot of bugs on that. We have more problems with the firmware than we do with the OS, right? So, but in our white box experience, where there's a BIOS that doesn't do much of anything, controls the fans, controls, it doesn't reach into the cards and the HBAs and the next, so they can't do a lot of diagnostics, but because they're not reaching in there, they don't interfere with the applications. I rarely have a BIOS bug that interferes with an application on white box, right? That's what I want for my scale out. So what I want to see is I want to see that complete standard that we define. Here's the 5 commands we need, right? And for those that we know, and sort of that's the base. They all have those 5 commands, right? And then there's, okay, what's the next layer, right? And when I go to a vendor, I can, and then they're standardized, right? It's a set command. So that when you write code, it's the same on a tier 1 and a white box or different tier 1s, it's all the same, right? And then maybe there's a third layer, which is that vendor's cute stuff that works against their cute hardware that they've IP, right? So you have base level just for scale out, very minimal. And I'm going to just add one thing to Marcus's 5, which is just basic power on, power off. I don't remember the whole list of 5, but it was just really basic. The one thing we do need on every server, including the scale out, is the ability to upgrade firmware, right? BIOS, card firmware, and in an automated, rapid way, right? With the exact same command structure, so that I could literally do it. Obviously, it's going to be a different payload for different models and stuff like that. But the automation could be the exact same. Because usually, when you do have a BIOS or firmware issue in a scale out, this is not an injury to one server. This is a disease in your herd, right? And those are things in the scale out we have to fix rapidly. So those, so being OS independent ability to upgrade firmware and BIOS is something I think we need to force add in a very consistent way. So this is what the syntax is going to be. Obviously, different payload is we're not going to get one BIOS for everybody. That would be great, but and go there. So, anyways, that's what we really think. And then the next level, all the cute stuff, diagnose stuff, and all the things that you'd want on the more advanced server. When at 2 in the morning, you've got to get it up as quick as possible, and you want all those extra features, again, consistency there, and then giving vendors the ability to say add a third thing. But what I want to make sure I can do when I buy a server is I can say, look, it's not a case where I want layers 1 and 2, but I'm only going to use 1. I don't want layer 2 if I'm not going to use it, because that's code that causes bugs. Last thing I want to do is call and say, you have to roll out new firmware because there's a security hole in this piece of the code that I don't even use, right? So that's what I would think. That we'd love to, get the calls to start contributing to that. Let's define that layer 1, thinking scale out, bare minimum, hyperscale, and enterprise scale out environments. Then layer 2 with the more sensitive systems, and then obviously vendors can do their own money through it, right? That's what I'd like to change.
Thank you.
Okay.
We had John Stewie join us, co-chair for the server committee.
Let's go to
So
the next.
let's just see who is using OCP today. Okay. That's, And for the people who are not using it, doesn't even talk about the reasons why they are moving in that direction. They're following that, but looking to get in. What's going on? What's the mind? What's the thought process there?
So I think today, if you look at the what's the provided in terms of hardware, is there something that you think it's a blocker for adopting the OCP solutions? I mean, can you essentially, is there a feature we say, if that feature is there, I will go and buy this hardware, essentially. Or vice versa, if there's something that says, okay, I'm not gonna use it because of this feature, right?
All right, so we do use some OCP. It's actually not as much as we'd like to be using. So here's the complexities. The problem we have is lack of product, right? So you mentioned the 19-inch versus 21.5-inch, and so we've been doing OCP since the beginning, and we've been trying to go all in on the 21.5-inch. We see the value of power disaggregation, but we do realize there's complexities with trying to get there. But the one thing we need is product, right? And there's really not, even still today, much product in that space or enough for us to really start to absorb. The issue is that our needs, we first looked at Winterfell, it wasn't enough management for us, right? So we're still trying to get down to the 5, right? We still need a little bit more, right? So we were looking for something that had more of a white box BMC implementation, right? Sort of a standard IPMI, you know, my support groups insist on having the remote console for some reason. So the problem is that we haven't automated everything. So we still do log into servers. Our goal is to automate everything so you never log into a server. And once you do that, you no longer need it. The problem is how do you get there, right? And then from the product standpoint, there's compute nodes, memory and CPU, the sleds and things like that. But there's not, you know, where's my Hadoop server, my storage server, you know, where's the 2U version of the OCP? There's the 1U version, but there's not the 2U. The only way to do the 2U version is to get the 1U with the NOx, you know, the JBOD thing, which is not really what we're looking for. And what we then want within that environment is we want the same motherboard, right? So I qualify the motherboard once. We went through this with the Decathlete and Roadrunner, right? We wanted the 1U and the 2U. We defined that we wanted the motherboard to be the same so that the BIOS was the same. You know, the work we do to qualify was there. But obviously the 2U was so that you could have environments that needed more disk or more PCI slots or something else that required the extra space. But if you just needed compute and memory, then you just got it in the 1U version. So I think OCP is starting, we're starting to see some people providing the 12-volt sleds with standard IPMIs that basically, to me, replace that 1U fine, right? It's the 2U right now, I have to go to a JBOD, which is not ideal. But, so that's part of what it is, we just need product, right? But I agree, the supply chain problem is, well, I'm saying I want 21.5-inch, Rajiv saying he wants 19-inch, right? So we, you know, even us that's been here from the very beginning and talking to these guys from the very beginning aren't all exactly on the same page. But I like the idea that if you get the same motherboard spine, right? And the 1/3 sled is a half 19. It actually works pretty well, right? So you could do 2 of them in a 19 and 3 of them in a 21.5, right? So then it's just sheet metal, a few pieces around there, and they can leverage that stuff. So that to me is what's holding us back from being much further down the road of consumption than we should, where we are today.
Thank you. So I think, I don't know if people noticed, but I definitely noticed a few 19-inch form factor 2U quads out there in the expo hall. If you haven't seen it, please go see them. Those are using the Leopard motherboard, the same motherboard that's there on the Leopard 21 and 21.5 system. And they're just replacing, instead of DC bus bar, they're putting a power supply and wiring the same back into the build PC that they would have been through the smart. It's a definitely interesting sort of convergence right there.
Yeah, and those systems, the specs are out on the server wiki page for those systems. But it, I think again it'll go back to what is really the feature set, because when I said this morning, I heard in this room, I heard, hey, like Winterfell or whatever was missing this, missing that. It was all with respect to those systems where they're saying, oh yeah, we'll use the big version of BMC versus the little version, and you'll get the management features you want. And so, how do we decide, what it is so that people don't have to go off and change boards, or even get different versions? Because once you get a different version, all of a sudden it's different firmware.
I think that one of the interesting things he was getting at there is this idea that there's always a legacy application. So, from my perspective, when we initially launched the selling of the individual open compute servers, we said customers should treat these like cattle. Like, I like your analogy of a disease. That's a really good way of putting it. But there are always legacy applications. There are always things like MySQL and MariaDB, which aren't ever going to work in real cloud-like scenarios without significant engineering. And so I sort of think there's this dichotomy of where a lot of the open compute technology is being driven by hyperscale companies who have solved all these problems years ago, and now we're trying to adopt it for, my customers or for Fidelity, who haven't quite made that leap yet. And so it's not that I need those features on every single machine. It's that I need those features on 10% of machines, which is a big enough number that I need them on almost all of them at that point, because you've got the legacy workload and the new workload. And I think you sort of have that disconnect between the bigger players who are designing this and sort of the smaller to moderate size that are trying to adopt it now.
And you think just for argument's sake, you don't think that for that 90% adopting OCP, and leaving 10% to those high-featured custom at this point? I get the idea that we should solve that problem collectively. That's totally great. But is that something that you would consider, or that becomes a blocker to OCP?
I mean, I always saw part of the, and I'll admit I'm more of a software developer, software engineer than I am a hardware engineer. But for me, as a developer, there's value in having cookie cutter systems and knowing that when I'm troubleshooting my database server and my web server, that I'm dealing with the same motherboard, that I'm dealing with the same firmware versions, that I'm dealing with the same hardware and performance semantics. Even if I never look at the console or I never attach virtual media to the web server, the fact that they're all running the same is a huge value, because it gives me that virtual machine-like consistency with the bare metal performance.
So, Rajiv and Bharati, you guys had a talk in your session this morning on open BMC.
Yeah. So
Tell
coming.
us about it.
So it's coming. So
For those of us,
So some of the firmware features, and so I can tell you, so I'm from Microsoft, so we have OCS, and our spec is online. So we provide IPMI, full-featured IPMI 2.0 OCS. So, however, we don't, the reason we provided it, we don't need most of it. We need 5 functions in our cloud, right? We don't need much of it. However, we thought, okay, this IPMI 2.0 client, let's put it there, right? And then when you go get off the shelf BMC, you get most of the features with it. So we did not see a need to deprecate the features, although as I said, maybe there is a value for it once, but we thought, okay, there is an upside to including being compliant, IPMI 2.0 compliant, there's a value there. So we did. However, even if we look, and I'm sure, I mean, some of other hyperscale, they have IPMI 2.0. However, it's not really fully interoperable. And the challenge is we try to have an interoperability kit, right? And where we discussed it, we have even a committee, and then it did not go really far because there are tons of challenges to having who's going to test it, what type of kits you're going to use, what does the stamp means. So it's a lot of problems, lots of obstacles, right? So the question is, how can we have a cookie cutter IPMI 2.0 where we can say, this is a blessed OCP IPMI 2.0. If you need the feature, add it and ship it across all platforms, right? It's not easy unless you really have a common shared open source. Yes. This is coming from a soft firmware engineer, right? So it's hard. It's really, there's no way you can enforce interoperability unless you have some piece of code that says this is it, use it. If you want to add something, add to it and make sure it's available to everyone, right? So we think OpenBMC could be that platform, right? But it's going to require lots of upfront investment from everybody in the OCP and everybody in the community, right? So we think there is a solution there, right? Now, for the OpenBMC, obviously there is the interfaces, but again, if we have a shared source code, we can force that interface as well, because it's shared implementation, whatever the interface is, everybody will converge on it. So I think we have a story there. The question is, how fast can we move there? Again, it's going to depend on it's going to take some time there, because to mature it, it's going to take more than a year to get there. Now, for UFI, obviously somebody mentioned firmware updates, right? And that's for tools. But even in UFI, there are very subtle features there in UFI. Something like virtual media you can put in BMC, but you can put in UFI too. Can you have virtual USB to boot? Can you boot from virtual USB? Right? It's not there in most implementation, and OCP doesn't do that, right? I mean, there are lots of other minor details, but it's crucial to some use cases, and it could be a problem. Then you go to the tools. How do you update UFI? What tools do you use it? Is it the same tool across all OSs? What is the capsule? We had a discussion this morning about the standardization of UFI updates and how you update option rounds, how you update BMC, how you update UFI. So there's a lot of issues there. So again, so that's UFI is really a challenge. Run into people in the hallways and, hey, can we use ETK too, right? Again, so it's an open, UFI. UFI is much harder not to crack than the BMC. But definitely it's an area which we need to standardize on as well. Diagnostics, this is the subject. I mean, how do you diagnose? Suppose you have a problem with the server, and we have a set of tools, open tools that we can ship part of the OCP that, hey, run these tools and it can run, and for whatever X minutes it comes back and tells you here's the problems, go fix them, or here's error logs, go and parse it for you. Because today, even the SEL with the system event log, you get lots of binary error codes, OEM error codes, which means nothing to most of the audience here in the room, right? So at Microsoft, we went ahead and we parsed them and we built the chassis manager. So we have a chassis manager which goes and pull all those data and interpret it and convert it into text, right? But for most people who go and grab the raw SEL system event logs, some of the errors don't mean anything. They are just hex codes, right? So how do we solve that problem? Rack management. So again, so I think probably we are the only one who has a rack manager submitted, right?
I think so, but every once in a while you see a box out on the floor. I don't know if I saw one this year that has a little tiny arm, and then some non-standard open rack extension to talk to the rest of the rack, but it's all non-standard.
So I mean, we talked about OpenDCRA this morning. So OpenDCRA is one who's trying to tackle by doing power line communication and putting a Raspberry Pi at top, or putting some module in the switch itself, which is connected to the same bus to do that. Again, challenges.
It's a challenge. For OCS, we gave the hardware, we gave the software associated with it. there are challenges there as well. I mean, it runs on Windows. Somebody also valid has to go with Windows license. We are looking into that, right? So stay tuned. We may have some solutions there from hardware as well as the software. There is actually an activity that started, but I don't think it went far into taking the hardware and implementing a Linux chassis management stack on top of it. But I think this problem hopefully we can solve within a year. So, or maybe sort of.
Yeah, that's a good point. It takes time. It takes time to make these changes. And so what we're asking for is feedback now, because we may come out with a proposal and then say, here's the thing. And you say, oh, but you're missing this.
Sync this feature X, Y, or Z.
What I really wanted was six features, and you left the sixth one off because I forgot to tell you about it. Like we don't want that to happen.
And that's actually why we are here, because as again, it takes like 12 months to 18 months to implement something. So if we are in the process of doing something and we want to provide it to OCP as a collateral, it's better to tell us now because the cycle is long.
I'll add two things. One of these I said earlier in the firmware update, but around security, there's two really important things. And a lot of the security is around validation or signing to make sure that you can't put a bad firmware on. But in the case of where you're sharing hardware across multiple people, maybe in our case they're completely untrusted, but even in large organizations, it's only a small trust with the user running it. Being able to pull the firmwares out and validate that they're the same is important. And a lot of hardware today is missing the interface to say, give me back the firmware you're running. As one thing. The other piece that I desire, I've been told by other people who work on OpenBMC, this is like asking for a pony too early in the process, but the ability to completely sever in-band OS from being able to modify firmware, from being able to communicate with the BMC so that you can truly operate a machine. And we do some of that today, but it's difficult with the current architectures to do that. But in order to do that, that means you have to have firmware updates to be able to go through the BMC. You have to be able to have BIOS setting changes go through the BMC and all that, so that you end up where maybe a root user doesn't have as much hardware access directly as they do on the average server today.
So you're trying to provide even a root user admin not to be able to.
That's my life. I mean, we provision machines to people, have to secure them afterward for reuse.
But you give them admin access to the machine.
They have full root access, no hypervisor.
But you want to introduce another privilege, which is almost like bring -1, whatever, or more than an admin, hardware admin.
I want to trust my out of band more than I trust my in band, because out of band I can keep control of, or even in the non-customer case, the IT group has control of that management, and the in-band users can't modify their own operating environment.
Something like a provisioning mode versus use mode, where
that's almost exactly how we have it implemented for custom BIOS.
You have a provisioning mode where you can do what you want to do, whether you're booted for big C or remote, and once you lock it down, the only way you can get to is okay.
Yeah. Well, the question is, I think the question would be there is, when it's in provision mode, are you trying to protect the data from the IT people managing it? Because that's kind of interesting, because then the security goes both ways. Oh, that's interesting. I would like that. I would love that as a feature for my customers. I can't touch your data.
Yeah, you heard of Jeffrey Snowden. What was he? He was an administrator.
Yeah.
So yeah, you want to protect both ways.
Yeah.
You never know who you're gonna get.
I mean, something that I mentioned to someone at HP once, and they told me I was having a little bit of fantasy with this, but almost the idea of having a factory reset in the BMC of an API call I can do that will secure erase all the disks using the proper ATA commands, that will reset firmwares preferably and settings back to some default things, so that in that case, as an IT administrator, I could still take your machine away, but you could know that before I took it away, your data has been wiped off. And all the pieces exist to do that, just not necessarily the unifying standards to make it where it can be done in one button. And so Ironic is trying to meld that a little bit today with some of our support for cleaning, but we certainly can't declare that where we can't touch your data because obviously you have to have access to the hard drive to issue the secure erase commands today.
Unless the user himself is encrypting the data with their keys.
Well, if our users are that good, I don't think I would ever need a console.
So this is the firmware features. There is a hardware also a feature set, which kind of actually we know firsthand. I can speak to it, so we can talk about it.
Yeah, so, an interesting thing is in our journey in OCP, actually our journey in Microsoft was, we came in and we said, no frills hardware, Microsoft hardware, no frills, there's no VGA whatsoever, and we've been fighting that. We've been fighting that uphill battle for years. And the thing is, we thought that we would architect it, get everything all working so that, you just don't need it. But the reality is that there are a lot of things out of our control that we didn't realize. Technicians without network access because you can't trust them. You can't trust them with the data, so you can't even let them get into the machine. So, all sorts of things like that.
So not even that. If a motherboard goes bad and your motherboard gets replaced, you want to sanitize it before you put it on the network through USB stick.
That's one use model.
Yes.
And that's
Unless
that's
security comes and says no USBs. Period. End of discussion.
that's us.
Security guys don't like USB. It's just
So this is one thing that we that we're looking for feedback on because we're starting to tip over on this. Maybe we should. Taking it away just hasn't made the need go away yet.
Feedback.
Yes, feedback.
Yes.
Yeah. So VGA. So this is actually a funny funny problem for us. So we were worried that we're the same thing, right? Vanity free. Hell no, we don't need the VGA. Take it off, throw it away. You get your first server in the lab, and everybody's going, how do I start? Right? It's
graphics card on it.
We actually have a harder time with it in the lab, but we know that when we start deploying at rack scale and 10 racks at a time, and all our automation is done, then we shouldn't need it, right? So it's sort of a catch-22 again, right? So we get that first one and fell. The first thing we're doing is putting a VGA card on the thing, right? So and we're like, wait a minute, we're not supposed to do this, right? The sideband, out-of-band, you're going to run into company differences here. Fidelity has totally separated out-of-band management, so we can't use the same card. Fans, that's interesting. I actually never thought about that. I guess a whole efficiency investigator sort of. So we are strong, just like I said in the power supply, we're a strong believer in disaggregation across the board. But we see the power supply is something we can do today with a 12-volt bus bar, right? And again, the advantage is that, and all the research we've done, the money you save by removing power supplies in the servers does offset the extra cost of the thing. So it actually makes it fairly flat. You will see the slight savings. But when you replace your servers, on the 3 to 5 year cycle, you're not buying more power supplies. So that's when you start really saving because the power supplies are going to last 2 to 3 server cycles, right? Where normally we're throwing them away, right? So that's where, and I guess the fan is the same question. Disaggregating a fan, and I'm throwing away fans too, right? Every time I throw away servers, they're still working. Hot plug power supplies, well, 12 volt, I don't have to worry about that. And yes, in the rack, I want a hot plug. The next, I believe in the MES card. I like the MES card concept because everybody's got different requirements. I'm 10 gig, I'm 40 gig, I'm still 1 gig, right? And the last thing we like is, you buy a server and there's the 3 onboard NICs that no one ever uses, right? And because we had to add a PCI card for the 1.4 or whatever it is, right? For some reason, ours are always 3. I'm sure what they all do.
They've run out of board space.
Right. So, we just, we do believe that the standard network, the first network interface should just be a mouse card, and then people can pick, right? And then for the number of HDs, again, our belief, again, scale out only. So let's just stay with scale out for a little bit. A single SSD boot is all we need for a compute environment. And then I talked earlier about other types, the Hadoops and stuff like that. At that point, that's the add-on, a whole bunch of HDs. So that you still just need the one SD for boot, right? Because again, I don't care if a single server dies.
So I have a question about the mezzanine. So there's the OCP mezzanine that almost everybody thinks about, and then there are the two additional OCP mezzanine form factors that go with Open Cloud Server, right? And what I see in the mezzanines is a number of ODMs have their own version. Every ODM has their own version of the same card with different firmwares and that sort of thing. And one of the strategies that Microsoft has taken is we say no to that, and we prefer, if it's a mezzanine, whether it be a mezzanine or an adding card or anything, we prefer to go like straight to the vendor, because then we get one firmware.
Right.
It doesn't matter what it's plugged in.
So I completely agree. And I don't know if you guys remember when HP did their cloud line last year, they actually mentioned that on the stage, that they were going to deliver a cloud line PCI cards with the firmware from the vendor, right?
Yeah.
The reason that the tier ones change the firmware is so that they can get the fingers of their BMC into that card. That is exactly the reason why we have 15 firmware outages every year, or firmware issues every year on tier one, and we don't have any on white box. Because again, the white box doesn't have the capabilities, but at the same point, then you don't have the problems, right? So I agree, and I'm going to sit and say, with the firmware just being from the main vendor, whether it's a NIC card, an HBA, or whatever, you're going to have less bugs, because when the tier one add, they're adding to it, so you still have the bugs that the original guy had, and you have their bugs too, and then you have the BMC bugs as well that get triggered. So again, less code is better, and less cube tricks cause less problems.
So then it goes back to, what is it about the mezzanine that's magic, that's special? So I see Harry back there. He might have something to say, but because
special.
Well, versus a you can buy an Intel NIC on a PCIe card, or you can buy an Intel mezzanine card.
What's the difference?
Yeah.
Yeah.
Besides the physical differences,
so one thing,
why would you do one over the other?
So one thing is, that's a whole reason why we think about the mezzanine card in the beginning, is in between, either I put it on board or buy a PCIe card, right? So at the time, there's only two kind of economical way to do that. But definitely not on board, just like what you just mentioned, exactly that reason, because I don't want to be a regret. And on the PCIe card, the time is actually facing tracing the space about what other stuff I can put in. If I just put a NIC color as a must-have, they're already taking out one very kind of precious space there. So we make the call is actually go to the mass. And as of today, the magic happens is like the ecosystem is actually building up around the mass, make it like economy-wise, is pretty much comparable to all the standard PCIe card. So then I think is getting to the sweet spot is like right now people can have multiple choices on the mass card. We can have a OCP mass card spec keep evolving forward. At the same time, for the standard, everybody can buy the HBA, the recard, flash, all these other stuff. So you don't need to facing the dilemma like
So my takeaway is, you have space, you don't want to use up valuable slots for a NIC that really belongs down on the board.
Because the NIC, you have to have it. The point, the key difference is the NIC, you have to have it for every server. So you don't have a choice. But for HBA card, for RAID, for others, different configuration, you may not have need it. Yeah. So this is especially when we are looking at some people is using the mass card, why they are kind of considering it, especially on the one use space, is they only have a one PCIe card can plug there. Yeah. So
Okay, can I change my hat?
Sure.
So I'm going to take off my sort of the OCP management track hat and wear the Goldman hat, turn the side of the table and probably talk about my viewpoint. Like sort of let's contrast with
You're right.
both fidelity.
Your input is welcome too.
Sorry. I'm right in front of it. Okay. Okay. So some difficulties in changing the sides. Right? So VGA, no VGA. When we started our OCP journey, as sort of Bob said, there was no VGA on the board. We got into the lab and the guy said, "What am I doing here?" It's like, what do I see? What's going on? So we put a VGA card in, and okay, we said, for the lab purpose, for certification, you have to put a VGA card. When you have to do the power measurement, remember to take it out because you will not be putting this into the field, right? So we did that. We did certify the thing. We put it into the field, and then the first time we had to replace the motherboard or do something where the Pixie was not booting. For the simple reason the switch was not configured. But I don't know that until I get to this screen to say it's not working, right? So we created from a debug header to a USB to a sort of on the card consolidator, serial port consolidator, which gets over network to the guy sitting in his office. It was like a 5-cable jumper, which we said we're gonna put it on all of this. So VGA seems like makes sense because there will be situations where probably we're gonna need some way, shape, or form, some sort of VGA. Now, if UEFI or legacy BIOS can support a USB dongle to a VGA converter, probably we can get away with that. I don't want that 5-cable Frankenstein sitting there. Right? So that's where it is. VGA through BMC is an interesting idea, but again, it's a challenge. What if BMC is not getting an IP address? That's really the concern.
No, this is
Yeah.
this direct attach. We don't need an IP.
Okay. During the okay.
PCIe.
Yeah. That'll work. That's a concern. Side band, out of band. We don't have the luxury of, or we made the choice ourselves to not go out of band. We do 100% sideband in CSI. Some people are looking with their sort of spatial looks, but that's fine. That's how we are. So I think that's one of the reasons we don't want to go to a PCI add-on card because most of the PCI add-on card uses I cannot do that.
I thought the PCIe cards usually have a little cable headers. No.
PCI cards typically have an I2C bus and they go into the OEM books, but not for management, it's for inventory. So,
You may use one CP keep it on the
Yeah. I mean, even if one card vendor may be doing it, I don't know, but that limits your choice of what you can put there. Severely, right?
Right.
So,
Yeah, maybe the cards that we saw, maybe like the OCP mezzanine cards, maybe they were custom built by the ODM and not actually from a central source.
Commissioned by OEM.
Yeah. Okay.
motherboard fans or rack fans are concerned from anything that spells, smells, or looks like blade. We want to stay away from that. That's the reason we have been in a single one-use space, commodity space. Put as many as you want. Your failure domain is one cell, right? And we have sort of stuck to that. Not willing to go to maybe 2U quad, 1U server, 2 server, but nothing more than that. Anytime you're going to put a fan level at a rack level, you're going to have something that's controlling those fans from an aggregate point of view, and that sort of becomes a big concern. Not unsurmountable, but that's concerning. Natively support M.2, U.2, don't care. Don't need it.
You don't need flash.
SSDs.
Simple SSDs, and now if those SSDs or NVMEs come with M.2 on the card, that's fine. But on the motherboard, I don't really. We use local storage for our scale out, completely no SAM, nothing. So we're gonna have the drives anyways there, so we just really
The question on the two is how to division space, optimize the
yeah.
optimize the Any opinion?
I haven't thought about that, but from purely from a company perspective, I think we're gonna have some sort of a PCI, either flash card, NVMe or whatever, or we can have front-loaded disks. So, you know, pick your choice, whatever you want to do with space. Hot plug PSUs, that is a requirement because we use, I mean, we have two environments. One environment is totally grid computing, kind of we have single power supply, don't care, server dies, shoot it, we'll take it out 3 months later. Whenever we get time, that's a different environment. But in our cloud environment, we do use swappable power supplies because if the server dies, a guiding principle for the application owners is that you have to replace. It's a cloud environment, you say, spin me another one, you get it somewhere else. But reality is we're not there. From a provisioning perspective, we are there, but from an application owner perspective, if during the trading time I tell him, I don't care, go and replace your machine somewhere else, doesn't fly well with the application. So still need hot plug PSUs. We have talked about can we do a more reliable single power supply which never fails guaranteed. The challenge there is with a single power card, if there is a data center meeting, it's going to do A side, B side, that becomes a challenge. A built-in NICs or third-party NICs, definitely not built in, as we said, not on the motherboard. The reason we like OCP MES is for the single reason, because we're not going to go PCIe around. For this reason that we are in CSI, OCP MES gives me the luxury of certifying that particular one NIC. I can use it across different vendors. I don't have to worry about it's a Supermicro or MES slot or it's a Microsoft MES slot. The same MES. HDDs, how many? For a scale out, we are using PCIe flash, so doesn't really matter. For other use cases, where we are using for big data or what have you, standard 2U, the 12, 4 terabyte or whatever the sweet spot is that time is. And argue with myself. Why am I doing what I'm doing?
The question
Yeah.
on the
Question on the OCP MES card. It was very clear that we need an entity that's removable. Maybe the new question is, should that form factor be the OSP MES card or should that form factor be PCIe? What's the number?
I think he said it earlier. The PCIe is too big. It takes up too much. Look at the graphic cards. It's heavy hard, right? So it takes up a lot of space with the graphic card. You're basically what you're doing is making the place for the on the top. And I just use that.
Rephrasing the question, what if we use the PCIe connector?
Yes.
Space.
not as
Yeah,
dense as
it's a space.
Yeah, if you look at, so to Harry's point, if you look at the board, you have an open rack, it's like 2U tall, right? And you've got a few slots up here, and you have this MES really tight down with the motherboard. I think that's your point on that.
The other point is if you look at the one use server, I mean, most servers will give you 2 PCIe slots. If you're lucky, there's somebody who will give you 3. Right? If for our use case, if I'm going to put a PCI flash on one, and I want to use that server for some sort of HBA use case for my databases where I want to go OCP, now I need 2 slots. So having a NIC which is not consuming one of the PCI slots becomes very interesting. Not necessarily the scale out use case, but we will want to use it. All of this.
We have additional network
So I wanted to mention something about the first three items here. With the VGA or no VGA, it's nice to know that everyone went through the what the hell do I do with this phase with the first, it's like I haven't configured a serial console in maybe ever. I had to learn it again. The VGA through the BMC is incredibly helpful, especially if your environment is set up to DHCP the BMCs, because then it's just trivial. If you can't get to the BMC, you know, pull the sled, put it back in. If it doesn't DHCP at that point, or a man, like the troubleshooting is pretty simple. And once you get to that VGA through the BMC, it's nice. The downside being that's obviously another vector for hardware-based attacks. The sideband versus the out-of-band, the thing that the look of horror on my face is more about the application being able to access your out-of-band network. Like for me, I wouldn't even trust an internal application without level, much less if I had external customers as I do on it. So, you know, in that case, the physical separated out-of-band network is a hard requirement for anything at all Rackspace would run.
So just to be clear from that perspective, and we go through our tech risk review for all those things, but the view that our tech risk has is so long as there is 1 degree of separation between the two, you're okay. So either my application is sitting in a VM and there's a hypervisor in between, and VM is on a different VLAN than the hypervisor. That makes sense. If I'm going to put my application in a bare metal, then it becomes a different discussion.
That makes a whole lot of sense why you made that design decision then. We obviously are dealing with the people on bare metal. The motherboard fans versus rack fans, the interesting thing about you saying it's a single server failure domain, because I've been bitten by that before, the shared fans and having to be careful if you have one of the management engines out, the fans will slow down if you don't care for things like that. But the flip side of that is also, do you want a physical fan failure to require you to cycle that machine to shoot that node in the head? Again, I go back to the 10% case. If you're unlucky enough that the fan fell on your MySQL server, rather than having a DC operations person just go do a quick swap out with no disruption to service, you're having to do a full service disruption, which, you know, given that I'm the middleman in this case, not the person operating the server, that's a huge
I'm still
added
looking
piece
for
of
hot solver
complexity.
fan. I'm still looking for hot solver fan, but it is server.
Okay, I could probably be with you on that. It's just when I've seen the motherboard fan versus the rack fan, almost always the real differentiation has been, can I replace the fan without pulling the sled out of power?
I mean, it's an efficiency play because with the rack fan, you have bigger fans. So
I can tell you, Rackspace does it because of the operability concerns, not because of the efficiency concerns.
One of our concern is that some of the banking and probably Bob would have the same situation is around a lot of our applications want a predictable performance. So they want a guaranteed performance. It's not necessarily that it has to be the fastest or the slowest in the world, but they want a predictable performance. No jitter. So when a shared fan fails or something happens and sort of, you can say, oh, you can do power management and your CPU will throttle. That's not an acceptable situation.
It's just interesting where the trade-offs lie in that. It's a matter of what failure case you prefer.
Thank you, everyone. I think we're out of time, but you know, let's continue this discussion. You know, send us email, send it to the mailing list. Thank you. Thanks for coming.
Yes, I am. I've been an engineer since day one.